All right, today's daily, November 7th, 2024. I've got a solution that works, just not very well, but, still something to learn. Bitwise, the largest combination with bitwise and greater than 0. The bitwise and of an array nums is the bitwise and of all integers in nums. For example, for nums equals 153, the bitwise and for 1 and 5 and 3 is 1. For bitwise and, in case you don't know, it's if you convert all these numbers to their binary equivalent, so 2 is 1, 0, you anding them is saying, okay, so if at the same bit location, if both are 1, then it's 1 in the result. But if either are 0 or if both are 0, then it's 0 in the result. So what that means, I use the hints for this. What that means is that really we're just trying to find the bit location that has the most ones for all of the things in candidates, because we don't really care about the having more than one bit location can only drag you down. If you see, you only need to consider one. So if every number in candidates at the 0-bit position has a 1, then that's your answer. It doesn't matter what other bits they have set to 1. They can only drag that adding more bits to what matters can only drag you down, because it's and. It's not like or. It can't bring you up. So my solution was to convert all of the candidates to their binary string equivalents and to pad it with zeros, because then they'll, so this means, I had to look this up, means to take that number and get the binary equivalent with B right here, and then pad it with zeros so that it has a length of 26. I want it to be a 24-bit number because of this hint right here, and the 6 means that because a binary string will be OB and then the binary number. So I made this helper function, and then I map all the candidates to that function. So now I have a list of all of the candidates' binary strings. Then what I'm doing is I'm saying, okay, go through all of those bits. There's 24 bits, so go through all of them, and then count for all of the candidates in bit strings, how many of them have 1 at that position. So we use filter to take bit string. We filter it down to just the candidates that have 1 at that index. We then take the list, so then we can run the length function on it, because filter doesn't allow the length function. And then we just set the max, which the max combo is initially set to 1 because any number on its own would be an and of would return true, or would be and true, because every candidate has to be at least 1. So at the very least, you can just take a number as a combo, and that is anding against nothing, so it'll be at least 1. Then we take the max combo between either the current king or the newcomer, and then we would just return that max combo at the end of the day. I do think that this is a pretty elegant solution, but it's not the best, because even though it's only a few lines, and it makes good use of Python, converting things to bits and then also filtering out that entire array every single time, and yeah, it's a lot of operations on what could be a big array, and working with strings instead of numbers can be costly. What I saw as a solution that would work better was, I'm pretty sure this is essentially the same thing, except they don't map it to a string. Instead, they just use the bit shift, which I should have thought about, because a bit shift will, for candidate in candidates, if candidate and, basically, so a bit shift will just, this I will shift over that one that many times. So we start with I being 0, and then when we shift it over one time, we get 0, 1. So by doing that, we can compare every number to that and so on, and then we basically are getting the same thing, because by ANDing it with that, what we're getting is if a certain number has a bit at that location. Because if it does, then that will return true. It doesn't matter if it's 1, 1, 1, 1, 1. We just AND it with that, and we find out if it has a bit in the 5th position, or in this case, 2 to the 4th position. Yeah. So that's a lot better. It's pretty much the same thing, except done a lot cleaner. I'll upvote you for this. The upvote's not in a good location on this, in my opinion. I can never find... Oh, here it is. Yeah. So that's a much better solution, but I'm glad that I did mine. It's, a good example of I do mine, then I try to figure out how to make it better. But yeah, basically it's just this, except to make it better, you can work with bit shifting instead of string manipulation. But yeah, it's just a matter of finding out which bit has the most ones for every candidate in candidates. Awesome problem. Thank you for watching.